And welcome back to the morning show. It's Wednesday, Wise Guy time, and our resident genius, Matt Sellin, is back from a brief hiatus, traveling and getting more knowledge, and he's come back in a big way with water balloons just in time for the first day of school.
Yeah. So I want to just reiterate how this kind of thing works here. This is the first part of this whole thing is energy conservation, because as you stretch back a rubber band, it's like stretching a spring, and the energy stored is proportional to the square of how far you pull it. Okay, that all becomes kinetic energy, which is proportional to the square of the speed. So in other words, that means that if you stretch the thing twice as far, it's going to end up going twice as fast when it leaves this slingshot. And the distance it goes depends on the speed squared. So basically that says if we pull this thing back twice as far, it ought to go 4 times as far. So we're going to actually do a little experiment and try that right now.
Okay.
So we'll try pulling it back just maybe, this is very rough now, just a couple of feet like this, and letting it go at this angle. And you saw that it went maybe, well, you saw how far it went.
25 yards?
Yeah,
maybe?
Something like, well, maybe 10, 15 yards.
Yeah.
Now I'm going to pull it back twice as far, instead of there to here, okay? And it obviously went more than twice as far. So you can, so that the distance the thing goes like the square of the distance that this thing is pulled back. So in other words, pull it back twice as far, it goes 4 times farther. Now, I got a question for the viewers so you can win a prize that I'll send you. Okay?
Prize time.
Okay, now, imagine that I had extra surgical tubing. And so I put 2 strands of tubing, one on each, two on each side, so that this thing is twice as stiff. It's harder to pull it back. If I pull it back with the same force as I did before, is the water balloon going to go farther or not as far, or is it going to go the same distance?
Okay.
Okay, that's a good physics question right there.
So they can send it to your website?
Yes, they can. They can send it to my website and explain why it should go the same distance or farther or shorter. Okay. And just before we go, I got to shoot it one more time.
Be sure and give them your website, Max.
Yes, wciaguy.net.
Wciaguy.net for Matt's trivia question answer, not WCIA, wciaguy.net.
Okay, so we're going to try to pull this thing back as far as we possibly can now, just to see how far we can make this thing go. Maybe shoot it over that tree over there.
All right, let's see what we got.
Okay.
Now, there is science involved in this, folks. It's not just all fun and games, right?
It is kind of fun, but science is fun. No, science is fun.
And we prove that every Wednesdays right here.
So I'm going to pull this way back and hope it doesn't break, because that would hurt.
There's a kid over there, so.
Oh, well. Ew.
Almost. Hit the top of the tree.
Hit the top of the tree.
All right. How much time we have left, Scott? 30 seconds. All right, one more time.
One more time. This time I'll really haul it back.
Let's see if we can stretch those tubes.
Yeah.
Hold on, so you're twisting.
Oh, I am.
It might hinder our performance.
I believe it would.
All right, here we go.
Okay, so this time pull it way back.
Here we go.
All right,
get over the tree.
It's going to hurt if it breaks, isn't it? Okay.
Over the tree. Very good.
Oh, very good.
All right. Matt Sellin, our wise guy, thank you very much for joining us. And again, if you want to get the prize for Matt's trivia question, just go to his website, wciaguy.net, and answer the question. We'll be back right after this.